All right, we've got a nice task today, a fun task to plan today to rewrite the AI's code. Yesterday we had the AI review its code that it wrote. Then the day before that we had it write some code, and now I want to take that code that the AI wrote. Hey, Not01, hey, good to see you. We've got a plan for today. We want to. This is something that I just really wanted to do. Like I wanted to, we reviewed the code that the AI wrote yesterday, and I gave my own feedback on it, and the AI also provided its feedback. I wanted to take the approach and show you how I wanted to implement it, because there's so many ways to simplify and make it better. And just less code and overall less debt. But also a simpler implementation. And I just wanted to do that. And I figured, just keep it easy and nice, relaxed stream today, writing some code that is in the pattern that I like, the pattern that I think would make the most sense. So we've got the code up here on the screen, and I'm just gonna get started. I'm just gonna get going. I'm gonna make it simple. I'm gonna start deleting things. I'm gonna throw things out. We're going to get rid of things that we don't need anymore, and we're going to simplify things, because there's just a lot here that is not necessary, and we could make it really easy. So that's the plan for now. So I'm going to get going. I'm going to start cleaning some stuff up here. We don't need this. Do we need OS? I don't think we need OS. Well, we could use that, but we definitely want JSON. So I'm going to get rid of some of that. There we go. We don't need class. We don't need any of this. I'm going to keep some of this logic here because I want to create a date format like this. So we keep that. I thought that was nice. I thought the AI did a good job with, having it completed. So we could say, I want to have this method here, and I want to call it a new to-do. We'll just call it a to-do. And it's going to, I suppose we can keep it like this. And we don't need any of these things. We'll just say one, get things here. And then we'll have a task can be defined as a task. Here we go. And then we're going to just do something like this. And then it won't be completed. It'll be false because it's a new. And it's like that. False with a capital letter. And then we'll say created at a new date time. Here we go. All right. So this is I like this pattern. So already at the beginning, we'll worry about this. We'll worry about this in a second. And really what we want to do is create a list of lists based on yesterday's review. So that's what I want to do. I'm actually kind of excited. So let's do that. So we don't need self.data file. So let's we'll comment that out for now. And we'll go over here. And then with file and then we'll just call it out. Hold on a second. With open, do you have to, is this required? Do you have to give it a file handle? Maybe you do. Maybe that's something that you have to do. So let's see here. I don't like this level of indentation. This is not my desired style of indentation. So I want it to be like this, and I'm going to say f equals something like that, because there's no why do it any other way? So I want to double check to see if this is the right way to do it. Open file for read, then parse JSON. Okay, here we go. I don't like the width. I want it to be something else. I forgot. How do you do that? How do you do that in Python to open a file in Python? Open file in Python. I have to go over here to make it. There's an open for reading. I just don't want to do it with a with statement. It keeps everyone. How do you do without a with? Ruthick. Hey, Ruthick. Hey, how's it going? We're currently taking care of our desire to implement the recommendations that we made yesterday from the AI, which had written a simple to-do app, but it did it in a way that was just way too much. It way overdid the amount of code that was necessary. And I wanted to simplify it in a way that had the same level of capabilities in terms of it's nice and easy to use, but also just make it more robust and have it use way less code. Because it's doing things like pulling data into application space, and it's not necessary because you can maintain the data structures the way it's represented on disk in files, in a JSON file. So there's no reason to then implement it as a class structure because it's already represented in a data structure format that I'm interested in, and then we can do any sort of validations on top of it afterward. I don't want this to be an array of tasks. What I want it to be is in a sort of, what do you call it? Like, I suppose we can keep top level like this, but I want it to be an object of objects, basically. And so let's go ahead and get rid of these guys. Oh, hey, look, there's a next ID there. Oh, here we go. Already in the right realm of things that I'm thinking here. So now we can continue to keep this state as is, and we can have multiple readers and writers at the same time because we're writing against a file. Obviously, there's going to be a very rare chance for a collision opportunity, but as long as we keep reading and writing data every time there's a change, then guess what? It's going to work perfectly fine. We've got an array of array. Oh, wait, but it has to be the ID. This will be the ID. Perfect. Like, you could do it like that. That's fine. And then you can have ID inside if you want, or you can have it outside like this. I haven't decided yet. This is redundant. We've got some redundancy here, but the next will be 2, like that. This is the format that I like. I like this format because this will give us the ability to continue adding tasks with an ever-increasing enumeration. And then we can keep our structure like, we don't have to, here's why. When you're selecting which ID to modify, it's based on the task. You like a dictionary for easier lookup. It is, it totally is, right? It's exactly, you're totally right. This is because the previous implementation, look what the AI did. Here, check this out. It made a for loop. It made a for loop to go over, to find which to do to interact with. So when the user selects which to do to use, it always has to iterate through the entire list, which is a bunch of code that you don't need in the first place, right? So it's a bunch of throwaway code, essentially. Yigal, what are you doing today? What are you doing, buddy? We are, the last few streams, we had some AIs compete. So we had Claude Code, OPEX, or Codex, and Gemini compete for which one did the best job at writing a to-do app. Check this out. We saw, I basically picked Claude as the winner, Gemini as second, and then Codex also did basically as good. We're gonna delete this function because it's not necessary. Basically what we're doing, we want to modify the Claude version of that because I liked its interactivity with a while loop. I thought that was really clean because it's really nice for the user to manage and maintain their to-do list. So we're going to modify that code. We did a review of it yesterday, and we said, what were the problems? Today, I actually wanted to implement those things to show you actually what it really can be like. Because anyone can just comment on code and say, it can be better like this, or you can do it like this, and it's going to be like, sure, yeah, of course. Well, let's actually show you what it actually means to do it. So we're actually going to make it happen. Here's the cool part, guys. There's so much opportunity in automation today, building new technology, especially with AI now. It's the whole world is open. It's a wide open field. AIs can now do everything. And all the existing software in the world today has been written before AI was out. Right now, what you can do is you can just basically replace existing software, but doing it in the AI fashion, using the latest technologies in AI. It's the biggest opportunity right now in the market. We're doing a continuation from the previous stream and just kind of wrapping up the series here in having, the AIs competing against each other to which one built it. Raul, hey man, how's it going? Good to see you. Happy to have you here. We're talking about lots of different things, but we're going to get back to some coding here. So in the previous streams, I just commented, how inefficient some of the code was written, and by the AI, I'm like, you know what? We could do this way better. Here's better ways to do it. So what I want to do is we don't need this list anymore. Let's get back to some of the code. All right. So we're eliminating. So we already eliminated like 30 lines of code. Like it was crazy. So here's our new schema format. This is our JSON structure. And then we'll load this. So let's get rid of that. And then actually, let's go ahead and open that really quick back up again. Because I want to keep it as a reference because it's my schema. Control. So these common tasks, I do want to list to-dos. I want to complete to-dos. You can uncomplete a to-do, which is kind of neat. We're implementing all the things that we recommended yesterday's stream. In yesterday's stream, we recommended, we basically walked through this document, this app, and we said, we don't need this. We don't need this. And we're being very critical of what the AI did. So I actually figured, why not implement it? Implement our recommendations. So that's what we're doing right now. We're making it better. We're making it way better. We don't need self anymore. And we don't need to do it like this. So we just, look at this. Did you see that? Isn't that cool? Do you see we just deleted most of the data there? Isn't that crazy? All right, so this is our data. We could just, here we go. Data equals this, and we say return data. I think we could do that. We have 1 billion connected devices on our network, so we have to, we need to make sure it's fast. But however, Python, the syntax I like a lot. Isn't it cool? Yeah, I love it. It's really cool. That's what we use Rust for, and we've done amazing jobs with it, and it's really great, the team that we have that is constantly improving and innovating and replacing our Python with Rust. We're even at the point now, we have a lot of C code, and we're also replacing our C code with Rust as well, because it is that much better in terms of its ability to maintain and the concurrency and build more features on top of. We can ruthlessly refactor using Rust. And with C, we had to be careful. You had to be super careful. Uh-oh, is there a memory leak? Oh, no, not again. You know, that type of... We're still running C, but we're replacing it slowly with Rust. And it's doing a very good job. Hey, what are you coding? Okay, here we go. Edison, biggest fan. What we're coding right now is we reviewed an AI application that was written yesterday, and then we critiqued it the day after with a code review, and now we're doing the final follow-up as we're actually implementing the critique, because I felt like it wasn't good enough, because you could always complain about code. You could say, this doesn't look, I think it does. I actually kind of like this. I'm actually really excited to show, because this is a good way to implement keeping things simple is a really important aspect to this, because you can get really complex and then add all these abstractions and feel really good about it because you had a lot of fun doing it. But at the end of the day, you've created a whole bunch of debt for someone else to deal with, or yourself. The other person could be yourself. Reduce your code. Code reduction is important. How many years do we have to wait for a smart AI like Devin AI? We're getting really close to open source applications with Claude Code CLI. It has multiple agents built in, and it will do most of the work for you. It kind of fulfills the promise of what Devin was doing. Claude Code, you'll give it a task. It will implement the task. It'll run the code, and it will check to see if the output's correct. If it's wrong, it goes back and it makes modifications, and then it loops like that until it's done. And that's kind of what the promise of Devin was. Devin had some visual components to it as well, but so can Claude Code. You can add an MCP to give it vision, so it has the ability to run in a web browser or see what it's doing. Isn't that cool? So we're getting really close there. Teak, yeah, you're right. Code reduction is important because everyone logic is different. Yeah, you're right. Everyone has a different style, a different pattern that they use to code. And if you implement, if everyone just sort of went wild and they implemented it the way they liked, with as much abstraction as they wanted, then it's just unmaintainable. So the best way is to keep the scope as small as possible and keeping the code simple and clean, so that way you don't implement anything crazy. So like we're already on our way here. Plan for today. We had the AI write a to-do app. We compared 3 AIs, and they each wrote their own to-do app. We compared them. I said Claude won. Gemini was also good. It was the simplest I liked. And then Codex did a great job. Now, we reviewed the code yesterday, and then we're implementing our review. Basically, we took all the ideas that we had yesterday, and we're actually going to write them down. We're coding it today. That's the plan. So here we go. We're actually doing it. So we have here that just renders video in real time based on user input on the keyboard. So you're basically interacting with like a live video at that point. Look, games are going to be really cool in the next couple of years when they take advantage of this, because now you don't need to worry about shaders, right? You don't need to worry about vertices or UVs for painting the textures on meshes. You don't need to do that anymore. Holy glimpse. It's going to be really cool. They're just going to be games where they're going to be immersive. It could be like completely realistic, like real life, but it could also, it's like AI. We can build an AI. Actually, that'd be a lot of fun. I'd love to implement a neural network in Rust, because I've implemented multiple neural networks in various languages that leverage the GPU. Wouldn't it be cool if we did that in Rust? I think that would be really cool. Let's do a neural network in Rust. I like that idea. You can make your own Vice City, bro. You totally could. You can make your GTA Vice City, and it would be all your own, and you could totally do it, and it would work. JB, AI writes unsafe shaders. Oh, we got to be careful. Yeah, that's a good point. Shaders can be written poorly, and they can cause some issues, and the video card's memory could be impacted. Working on. Okay, we are rewriting the to-do app that the AI wrote, and I said it over-engineered it by a lot. And I'm like, hey guys, we don't need it to be like this. It can be simple, where it's moving data space into application space, and we need to keep it in data space. There's just no reason. There's no reason to put it into application space. See if we can actually get some coding go. What are you doing? The AI wrote a to-do app. It did over-engineering. It made it too much, and we critiqued it yesterday, and I'm implementing the critiques today. Then we don't even needed that, so we could just say return. They're simplifying things already. And then we don't need this here. There's no point for that. We just say return this. See, look how much better we made the code already. Look at this. Look, we've dramatically, now it's only 2 indentations, which is my favorite. And it does the same thing. Well, actually it's better, because if it fails, it returns the new file version. And the other one didn't do as good of a job for that, because it could have had an exception. Actually, we don't need this. We just go like this. Any exception. Boom! Look at that! Isn't that so much better? You can read it, you know what's going on, and it covers all cases. Isn't that great? JavaScript? No, this is Python. We're doing Python today. We're updating. So we've already reduced the code so much, and see, just like we've already reduced the code just a ton amount, and we don't even necessarily need this code here. We can even reduce that even further. Isn't this cool? What are you coding? We had the AI write a to-do list app. We critiqued the app. We did a code review, and I said, it's way overdone. It way overdid it. It over-engineered it. And so today we're going to simplify it to the level that I want it to be in. So that's what we're doing. Drawing Brothers Markdown file to presentation. That's a cool idea, Drawing Brothers. So you take a Markdown file, and it can be you can convert it into a presentation. Absolutely for devs. The question is, I need to integrate AI. Stand out among the others. How do I do it? So, how do you integrate AI for that? You could, well, actually, that's a really good question. We should ideate on that a little bit. What would make it more valuable with AI? You could have the AI render in different output formats, maybe. Instead of just presentation, it could be a document, or you could have it draw some pictures or diagrams. Like, that would be cool. Have the AI do some diagrams with it. So like, you've added on to your product. MD, upgrade. Do you want some diagrams? Here you go. And then you can have an upgrade. 5 free diagrams, and then you have to pay for credits or something. I have a thought about RAG, but that will cost a lot. Yeah, so here's Drawing Brothers. RAG, Retrieval Augmented Generation. You don't necessarily need to use vector store in order to do data retrieval. Often RAG they want you to use like the ideas like vector storage and cosine similarity to find other elements, but I do want to keep this. I do like this here. I thought this while loop was really cool. So we don't need any of these things. So we're already deleting a lot of code, but I'm keeping there for a reference. Have you looked at Pydantic AI output type? I use it every day. It's VB. Very, very, very useful for increasing AI use and reliability. Pydantic AI's output type. Let's take a look at that, guys. Let's take a little break from the code for a second. Pydantic AI output type. What is this? What are we doing here? What is this? Pydantic AI provides several methods to obtain structured output. Oh, yeah. Tool output. This is what I like this. So I use tool output a lot to do that, to get exactly what I want, because you can have the AI always return to you the exact format of data back to you. And native output is when this method requires LM to directly produce text content that conforms to provided JSON schema. That could work as well. Prompted output. In this approach, prompted incorporating desired JSON schema. So there's multiple methods here, it sounds like. My preferred method is tool output, which requires the AI to it forces the AI to start by responding with JSON. It's like a forced output. And it works 100% of the time. Rather than being deterministic, it's guaranteed. So rather than non-determinism, it's guaranteed determinism. Okay. The reason why the output type is because I can render classes of Pydantic base model. Then past this, I designed a game engine for learning that could fill a game schema for the game engine. It was cool. You totally can. I didn't even think about that. That's actually a really good idea. You can completely populate the data as well. Private Milo, yeah, I did. The way I approached it was step by step using Codex. I just wrote prompt and explained the flow. That works too. That totally works too. Try Codex next time. From OpenAI, that's ChatGPT 5, and it does a really good job. It actually did. We did compare it. It could have won. Like, I would say it's a close runner-up. We are rewriting an AI wrote a to-do app. It was overwhelming the amount of wasted code that it had. It over-engineered it. So we're under-engineering it at this point. We're actually the right amount of engineering it. That's what I think is a really great idea. So here we go. So this is the task. Spar optimization. Yes. So plus equals 1. Here we go. So we're taking the code that the AI wrote, which was over-engineered, and we're completely rewriting it. We don't need a self. We don't have a self. We have a to-do, so to-dos. Here we go. Beckham, what is he doing? We are replacing the code that the AI wrote with a simpler version. And that's what we're doing with the simplified version. We're going to do it like this. See, the AI is already doing it wrong so we don't need to try except here necessarily. We're going to do a write, open for write, and then we're going to file.write JSON dumps to do indent 2. There we go. Perfect. See, it already knew what to do. Then we do a save to-dos. Here we go. And I think refactoring some code AI did. That's it. Cosmos models I have used are Quinn at work. It's pretty good. And Kuro, Amazon's AI IDE. Yeah, Kuro's. It's like they did what Cursor did, right? They forked Visual Studio and they made the Amazon version called Kuro. It's really cool. There's some free tokens in Gemini CLI also. Yeah, Gemini is great. It's actually really easy to get started on Gemini. From a free perspective, it might be the easiest, and it does a really good job. We're almost there. We've reduced like 50. We deleted the entire class structure. Look at all this code we're not using anymore. We're just not using any of that code anymore. It's just like a ton. We've reduced the code size by more than 50% already. Isn't that crazy? All right, save to-dos. And we've made it cooler because now it's multi-user supported. Because we need to save and load. So we do need to save and load. So the save should also... Almost done, and we're going to run this and see if this works. So I'm pretty sure it will. Here we go. So we're going to load our to-dos. Perfect. And then we're going to do a while loop. So do we have everything we need? We reduced the file so much by a lot. And it's faster. It's so much faster. Look at this. Anytime we want to mark an item complete, we no longer have to do a for loop. Isn't that crazy what it was doing before? Look at this. Look at this ridiculousness. Every single time, it had to do a for loop to do anything, right? It's crazy what the AI was doing. And this is like, it's just so wasteful. It's absolutely we're going to be more coding. The plan is to do more code, more AI. We'll do algorithms. One of the things I really, hey, the like button. Thank you. Thank you for your likes. We are going to, someone was asking about Rust, and I want to write a neural network from scratch in Rust. I want to see him happy, and when he says goodbye, cool, thank you. Yeah, thank you, open source applications. Absolutely. We're going to make it happen. It's going to happen. Network in Rust would be very cool, wouldn't it? Not Owen? I think, so I've written a neural network in Python and in JavaScript and in C, and I want to do it in Rust next. I think that would be the next one to do it. From scratch, neural network with gradient descent and stochastic SGD, stochastic gradient descent, which just means randomized learning. We can totally do it. We can make it possible. We go. Yes, I understand, JB. Neural network in Rust. Let's see. We can add a task. Yep, we can add a task. We just need to rewrite this to, I think this is add, like that. There we go. Task input. It ran all on its own. I was expecting it to crash or have some sort of syntax error somewhere. All right, let's do 1. Enter to do test. Okay, so there it goes. It crashed. All right, so missing that. Probably because we need to have our to-dos. We need to do this. Here we go. To-dos. There we go. Like that. All right. And then open 1 test. Oh, wait. Oh, okay. Yep, we've got a F print here. All right, so we just like that. Task. Almost done. Little things at a time. We're going to make it. We're going to do it. We're almost there. Okay, test. It did it. All right, so 2 is going to fail again because we know we need to do, we haven't done 2 yet. So we want to list. We'll do list to-dos. There we go. Perfect. Now we should be able to, and my test should be there, so I should be able to say 2, enter, oh, print to-dos. We don't need that. There we go. See, we're reducing code already. It's making it already better than 2. Perfect. See, check it out. Excellent. There is a problem because I can see there's multiple. This is kind of interesting. I'm wondering what these ones here. What are these ones? Some interesting things here. And then 3. Let's do 3, which is a complete list. That should do it. I'm pretty sure that should do it. That's our schema, right? That's our schema. 4 to do task. Does it handle input? 4 to do task. Oh, if you input, we completed the task test task. So we did it. And see, it printed it out. It printed it out with the template string. Can you use template string? Yes. Okay, JB, thank you. Template string is what it's called. So yeah, that's what we did. So I think we did it. We full success. I call this success. Here's why. Here's why I call this success. It works the same way that it did before. And look at all the code we deleted. All this code down here. Plus, we deleted half, more than that. We deleted way more than that. So we'll do a side-by-side comparison. Check this out. Here's the before and after. Let me go over here to mine. You can see here, we got rid of this. We got rid of the class. We deleted all of these things. We deleted this entire class here. We don't need that anymore. Then we got rid of most of this class here. And so as you can see, the code, the actual logic, it's so cool. Yeah, thank you. The actual logic ends on line 51. And we could, to be fair, there's a few more things that it was doing. Like you can remove a to-do or you can unmark a to-do as completed. But you know, we could probably just like add 10 more lines of code to add those in. But yeah, see, let's scroll down to see when it got to the main app. Okay, so here. So we basically reduced, I would say, roughly 100 lines of code. And it does a better job in some cases. It handles some more errors. And it is more efficient because it doesn't need to use for loops. It directly is an object of objects, which uses a hash structure to do lookups rather than having to do in one notation lookup, which is very slow. Or not in one, or one of n. O of n. There we go. O of n. That's what I'm thinking. We don't have that. We have O of 1 now. An O of 1 lookup, basically. So we've made it faster. We made it simpler. And there you go. I think we did it, you guys. That's it. We win. Amazing. 2N API. 2NAB. Crisp. Yay, we did it. We did it, you guys. I'm so happy. I think this was really great. I got to show you. I get to prove. I'm like, hey, we can review this code and provide all this feedback, but I actually wanted to show you it was possible that we could do these, we can implement it in a much more streamlined way that was more efficient, fewer lines of code, simpler, cleaner, and just, just a better architecture. Simple, keep it simple. You don't need abstractions.